Welcome to the part 2 blockchain features of the Introduction to Blockchain series, where in this part we'll be focusing on the blockchain features, what's inside the blockchain versus bitcoins, and blockchain classification. Let's start with the first feature, which is chaining. Here we will see how the blockchain is formed. At the beginning, we should know that the transaction in a blockchain is recorded as blocks. A new block of transaction is linked to previous blocks in an append-only manner using cryptographic techniques. This type of chaining ensures that a transaction cannot be modified once it has been written to the ledger. From the previous slide, highlighting link to previous and using cryptographic techniques. What this means, the figure shows. As we can see that every block has a header that includes a reference to its previous block, which is the hash of the previous block. This structure creates the concept of chaining by linking the blocks to their direct successor and predecessor through hashes. The zeros are replacing the previous block hash in the first block, which is called the genesis. It's hard-coded and marking the start of the chain. Let's move to the next feature, the immutability. Again, back to previous definitions, highlighting append-only manner and cannot be modified, which means that data stored in a blockchain is recorded in a chronological order, and since it cannot be modified, it implies immutability. Therefore, the blockchain is defined as a system of records that simplifies the task of determining the provenance of information. Is blockchain tamper-resistant? Let's check. For the moment, we know that the blockchain has three characteristics, which is the referencing, the append-only manner, and the immutability. The below example shows that in case there is any attempt to tamper the data inside the block, its hash will be obviously modified. This hash, which is the reference to the next block, won't be valid anymore, resulting a break of chain. Conclusion: yes, blockchain is tamper resistant. The blockchain records all the validated transactions that take place in the business network, which can be represented as public or private peer-to-peer network depending on the business context. Peer-to-peer means that the computers participating in the network, which is referred as nodes, are all equal peers, hence they all provide network services. Also, one of the core benefits of the blockchain is the decentralization. The ledger is decentralized in the sense that the blockchain database structure is replicated across many nodes in the network, each of whom collaborates in its maintenance. As we mentioned earlier, nodes may take different roles within the network. The routing nodes are responsible for receiving and forwarding messages, maintaining connections with peer, validating and propagating transactions and blocks. The maintaining nodes are the nodes responsible for maintaining a replica of the blockchain and autonomously verified. The mining nodes are the ones participating in the process of creating a new blocks by running mining algorithms. The application-specific nodes are the ones that run application-specific functions such as smart contracts and digital wallets. At the end, the complementary nodes are running other specialized blockchain protocols in the network. To ensure that ledger transactions are synchronized, which means only validated transactions are written in the block and are written in the same order across all replicas, a blockchain network uses consensus mechanisms such as proof of work and proof of stake. Also, we have the smart contracts, which play a main role in supporting consistent update of information, enabling ledger functions, and automating the transaction management. It's time to see what is inside the block. There are 6 components headed with the block hash, which usually use the SHA-256 hashing algorithm. Then we have the pointer to previous block hash, which links the block to its successor. We have the timestamp. It's defining the time of creation of a block and maintain its ordering. We have the nonce. It's a random integer value that plays the main role in the proof of work algorithm. We have the Merkle root, which is the hash of all transaction hashes. It enables a quick verification of the blockchain data and quick movement of large amount of data from one node to another node on a peer-to-peer network, guaranteeing whole, undamaged, and unaltered data. Then at the end we have the transactions, which is a set of candidate verified transactions chosen from the pending transaction pool and forming the block. Sometimes we refer to blockchain as bitcoins, which is inaccurate. Blockchain is much more powerful. It's the platform for peer-to-peer applications, while Bitcoin is a digital cryptocurrency. The blockchain technology was originally developed by Satoshi Nakamoto to facilitate the use of digital currency, the Bitcoin. We can consider the blockchain as an operating system for applications such as Bitcoin. Depending on the application, a blockchain scope can be public or private. Public means no restriction on reading nor submitting transaction, while private is when submission is restricted to a predefined list of entities. Permissionless blockchain, there is no restriction on identities of transaction processors, while permissioned allows transaction processing only to a predefined list of subjects with known identities. This is the end of part 2. Thank you for your attention. If you are interested in mining and consensus mechanism, kindly watch part 3.